In this video, we are going to focus on congruency and similarity. We are still busy with the theme of geometry of two-dimensional shapes. So, there are a few key words that we first need to focus on. First being congruent, meaning the same size and shape. So, for example, if we look at these two blue notes, they have the same shape and the same size, and for congruency we use an equal sign with an additional horizontal line, so it's 3 horizontal lines. So therefore U is congruent to V. Also, if you look at these 4 flowers, they have exactly the same shape and they are of the same size, so they are also congruent. If we look at triangle W and triangle X, we can see if we turn triangle X, if we rotate it to the left, we can make it fit on triangle W. So therefore it's also same shape and same size, and therefore W is congruent to X. Now for similarity, the shape is exactly the same, but it is different sizes. So for example, this flower is a much larger version of the smaller flowers, but it looks exactly the same. It is just much bigger. So the shape is the same, it's just the size that differs. The other important thing that we need to focus on is corresponding. It means matching in the same position. For example, this angle here corresponds to that angle in the sense that they are in matching positions and have the same size. Similarly, this angle here matches this angle here. They are in the same position or matching positions and they have the same size. If we go back to this flower, when we use similarity, we use 3 vertical lines. So we can say the flowers in A is similar to the flower B. The other thing to easily distinguish between similarity and congruency is that similar has the letter M as part of the word, whereas congruent doesn't have. And this M I always think of as minimi and maximi, meaning the big and the small version. So if we now compare congruency and similarity, what we know in both cases, the shape is the same. So it means all the matching angles of two shapes, or all the corresponding angles of two shapes, needs to be the same size. So that applies for both congruency and similarity. Where the two though differ is that in congruency, all the corresponding lengths needs to be the same size or the same length. Whereas for similarity, it is the ratio of the sides that are in proportion. So, for example, we might have a triangle that is twice as big as a smaller triangle. So then each side of the larger triangle is 2 times the length of the size of the smaller triangle. So let's use exercise 11.6 to illustrate some of these concepts. So we need to use the information given on these diagrams to answer the questions that follow. So we are given various triangles. We have to firstly identify with reasons a triangle that is similar to triangle ABC. So similar meaning it needs to be a smaller or a bigger triangle with the same shape. In order to determine the shape properties, we have to look at the size of the angle. So we need a triangle with matching sizes. So you can see here we have a triangle with 111 degrees that match. You know, a triangle has 180 degrees, so if this is 111 and this is 43, we can obtain the missing angle. So we can say angle C is equal to 180 degrees minus the 111 degrees minus the 43 degrees. This is due to angle sum of triangle, which we know is 180 degrees. So we have now 180 degrees minus 154 degrees. And we obtain therefore 26 degrees, which we see is the same as this angle here. So therefore this angle here will have to be 43 degrees. So that angle and this angle therefore match, and then the 111 degrees match. So we can see we have the same shape. Now let's compare the lengths. So if we, in triangle ABC, between the 43 and the 26 degrees we have 30 millimeters. Between the 43 and the 26 we have 60 millimeters in GHJ. So this is double the length. If we move between the 111 and the 26 we have 22 millimeters. So we expect double, namely 44, which is indeed the case here between the 26 and the 111 degrees. So we can see the ratio of the lengths are the same. So we can therefore say that these two triangles are similar due to the fact that all corresponding angles are equal and the ratio of sides of side lengths are equal. So what we mean with that is that BC has a ratio of HJ equals 30/60, which is again the same ratio as AB over GH, which is 22 over 44, which is again the same as AB, well, not, I said AB over GH, which is not correct. It should have been AB is between 111 and 43, so it should have been GJ, which is 111 and 43. So this should have been GJ. So AB is in fact 14 and GJ is in fact 28. So we have 14 over 28. And then finally we have AC as a ratio to GH, which is 22 over 44, and all of these are the same, namely a half. Okay, so now let's focus on a triangle congruent to triangle ABC. So we still need the same shape, but now the lengths also needs to be the same size, so the corresponding lengths should be the same size as well. So 4326, 4326, so this angle has to be 111 degrees. Now let's see, we know that opposite the largest angle we have the longest side, opposite largest angle we have the longest side, so this side matches this side, and then opposite the smallest angle we have the shortest side, opposite the smallest angle we have the shortest side, and we see the 14 millimeter matches the 14 millimeter, and the remaining 22 millimeters here matches the 22 millimeters in triangle DEF. So therefore we can definitely say that triangle EDF is the one that's congruent. It's just right here, the one similar was GHJ, as already shown. So EDF is congruent. The reason will be all corresponding angles are equal, all corresponding sides same length. So finally I am going to work through one of the problems of my own creation. So we have to solve the letters X, Y, Z, U, V and W if these triangles are congruent. This one is very important in terms of one of the questions that in fact appears in your investigation. So we have triangle ABC and triangle DEF. We are assuming they are congruent, so it's the same shape and the same lengths. We can actually fit them on each other. So now what was given in this triangle ABC, we know all the sides. whereas in triangle DEF we know 2 angles and a side. So we have to use now this information to calculate the missing values. So Z is actually what we can calculate the easiest because we know a triangle has 180 degrees. So we can say Z equals 180 degrees minus the other 2 angles of 60 and 70 degrees. So therefore Z is in fact equal to 50 degrees. Now, we know there's a direct relationship between the lengths or the size of an angle and its lengths when we are dealing with triangles. So, we will get to that a bit later. Well, we can actually use it now because we see that this 50-degree angle is opposite 10 centimeters. So if these two triangles are congruent, then it means V will also have to be 50 degrees as it's opposite the shortest side. So next let's see what else we know. Well, we know that the largest angle of 70 degrees must have the longest side. So the longest side in the other triangle ABC, is 14 centimeters. So we therefore know that X has to be 14 centimeters. And then we therefore also know that the 14 centimeters in triangle ABC, opposite that BC, the longest side, we need to have the largest angle, namely the 70 degrees angle. So U equals 70 degrees. So 70 and 50 is 120, so we need still 60 degrees to get W. So now we have U, V and W, we have X, we have Z, the only one that is short is Y. And now we have already the length of 10 and 14, 10 and 14, so therefore the missing one is 12 centimeters.